These are the solutions for topics 2 and 3, test review, part 4. All right, so for number 1, it says, given the measures shown in the diagram, which two triangles are congruent? Okay, so you have to check all pairs of triangles to check for their congruence. So let's look at this first triangle. This first triangle up here, let's call it triangle 1. This will be 2, 3, and 4. First of all, notice that we have 2 of the angles in this triangle. And actually, that's the same thing for all of these. So we should be able to determine what the third angle is for all 4 of these triangles. So let's do that first. So 65 plus 45 is equal to 110, which means that there's 70 left over here. This triangle over here has the same 2 angles, 65, 45, so this has to be 70. And then this one's got 70 and 45, so the other one's got to be 65. And then I think this one's got, triangle 2 has different angles. So this one's got 45 plus 60 is 105, which means that this would be 75. Okay, so let's erase some of this work. Okay. All right, so although triangles 1 and 4 both have this side 10, they're on different sides because you can see that the 2 angles that are between the 10 here are 65 and 45. But for this one, for triangle 1, it's 65 and 70. So this triangle is not really structured the same way. But if you look at triangles 1 and 3, the 10 here is between the 70 and the 65 like it was in triangle 1. And then the other remaining angle is 45. So it's triangles 1 and 3, which are Q and S. Okay, so this is Q and S. And I labeled those triangles with 1, 2, 3, 4 for no reason. I didn't notice that they had the letters there. Okay, next question. Number 2. This is actually, we had actually done this Edulastic before. But it's been like a month or I think so. I think it was a good idea just to do it again. So this one says triangle LMN and PQR are isosceles. And since they're showing us that this side is the same as this side and this side is the same as this side, then we can conclude that angle L is the same as angle N and angle P is the same as angle R. Notice that I used 2 here, 2 arcs instead of 1 arc. That's because although at the end we're going to assume they're congruent, we're not given that information at the beginning. It's not until we start reading here where it says, what measure of angle P could be used to prove that they are congruent? Well, if they were congruent, you would have to assume that the angles were congruent. But at the very beginning, we're only told that they're isosceles. Okay, so if we want the 2 triangles to be congruent, that means that angle M up here has to be the same thing. It has to be congruent to angle Q. So if the angles are congruent, then that means that these expressions, 2x minus 26 and x plus 16, have to be equal to each other. And there's only one variable there, x, so we should be able to solve for it Okay, so I'm going to gather all the x's to the left, so subtract x here, subtract x here, and this cancels out, so we're left with 16 equals x minus 26. Then I'm going to add 26 here, add 26, this cancels out, and we get x equals 42. Notice 42 is an option, but we didn't answer the question yet. They don't want to know what x is. They want to know what the measure of angle P is. Okay, now at this point we haven't figured out the measures of any of the angles yet. But we could figure out what angle Q is. And the reason is because angle Q, or the measure of angle Q, is equal to x plus 16, which is, now that we know what x is, we could plug it in. It's 42 plus 16, which is 58. Okay, so angle Q is 58 degrees. Now, we only know one of the angles in triangle PQR. We only know angle Q. So you might think you wouldn't be able to solve for any of the other angles, because you could subtract two of the angles from 180 to get the other one. But in this case, since these two angles are congruent to each other, angles P and R, that's going to help us actually figure out what one of the angles is. So let's continue working over here. So the three angles together, angle Q, and I'm not going to write measure of this time just to save some space. So angle Q plus angle P plus angle R should add up to 180. Now angle Q we know is 58, and then angle P and angle R are the same, so we could just call them both angle P. And the purpose of that is that now we only have one unknown in this equation. It's just P. Okay, so we got 58, and then when you add P to itself, that gives you two of them. So we got two angle P's is equal to 180. And if you want to solve for P here, you have to subtract the 58 first. Subtract 58. So we get 2 times angle P is equal to, this is 22, I believe. Yeah, 22. I think I did something wrong. Oh, my bad. 122. Okay, and then divide by 2. This cancels out. Divide this by 2, and we get P, measure of angle P equals 61 degrees. So this is 61. Okay. Delete. Let's go to the next question. For this one, it wants to know for what values of x and y, what values of x and y would make the two triangles congruent. Okay, well, for the two triangles to be congruent, then the corresponding parts have to be congruent to each other. So, one thing I want to review on this question is the fact that the order of these letters is important. So, for line segments, for example, see, if you take MN, this portion, that should be the same as line segment PR. So let's go find MN and PR. So MN is this line segment here, and PR is this line segment here. Okay, so those two should be congruent to each other, which means that the expression 3x minus 9 should be equal to the expression for PR, which is 24. Okay, and then we can add 9, this cancels out, and we're left, I'm sorry, this cancels out, and then we're left with 3x is equal to 33, divide by 3, this cancels out, and x equals 11. So x is 11, so it's either A or B. And now we can look at y. So here's an expression involving y. It's associated with angle T. Okay, angle T is up here in the very top of the page, and the name is the last letter, T. So that should be the same as the last letter in the other triangle, which is O. So T should be the same as O over here. Okay, the expression for T is 3y, and that should be equal for the expression for angle O, which is 82.8. So then we can divide this by 3, divide this by 3. This cancels out, and we get y equals 27.6. Okay, so we got x is 11 and y is 27.6, which is option B. Okay, let's do the next question. This one is so basic that it can be confusing. The triangle below can be subject to reflections, rotations, or translations. So they're talking about the one at the very top without a letter associated. With which of the triangles can it coincide after a series of transformations? So it's just saying that all this testing you hear is on the fact that when you do a reflection, or when you do a rotation, or a translation, or even an entire series of those three, those are all what's called rigid transformations. And the whole point was that the lengths of the sides stay the same, the angle measures stay the same before and after the transformations. So if you notice, all of these triangles, all the sides were changed from the original 7, 9, and 2. B is the only one that stayed the same. So B is the answer. Again, it's just testing you on the fact that reflections, rotations, and translations, the distance between the points stays the same. Okay, number 2. Oh, I think this is the one that's like, yeah. Let's see. Okay, so all three of these questions are related. So let's look at the first one. The first one says, the image of triangle ABC after a rotation of 90 degrees clockwise about the origin is triangle DEF. And again, the order of the letters here is helpful. A, B, and C corresponds to D, E, and F in order. So it says here, which statement is true? BC is congruent to DE. Okay, so let's not even look at the picture. Let's just look at the order of the letters here. BC, should that be the same as DE? No, because BC is the last two letters, and DE is the first two letters of this one. So that doesn't work. Let's erase that and scratch this option out. AB is the same as DF. Let's see. AB is the first two once again. DF is the first and the third. So that doesn't work. Again, I'm not even looking at the triangle. And then option C is that angle C and angle E are congruent. Angle C is the third one, angle E is the second one. Those do not correspond. So they're not guaranteed to be congruent. They could be congruent if it just so happens that B and C were the same and E and F were the same. But that's not guaranteed here. And actually, these triangles look scalene. But, okay, so C doesn't work. And then option D is that angle A and D are congruent. And that has to be true. Okay, so angle A and angle D are congruent. Okay, let's look at the next one. The next one says, oh, I shouldn't have deleted that. So this one right here. It says if triangle ABC is congruent to DEF, which segment is congruent to AC? Okay, well, AC is the first and third letters in this sequence, so it should be the same as D and F, which is option C. Okay, number 4. If triangle TRI is congruent to triangle ANG, which of the following congruent statements must be true? Oh, so this one's actually not related. This newest question is not related. Matter of fact, let me just erase this stuff here and just zoom in here. Well, let me take another screenshot. Okay, so here's number 4. All right, so again, this is testing you on the fact that these congruent statements, they can't just be written any possible way you want. It has to be that the first angle corresponds to the first one here, the second one here with the second one here, and the third one here with the third one here. So option A is claiming that TR is congruent to AN. That's correct. They're both the first two letters in the sequence. So A works. Option B says that TI is congruent to AG. TI and AG, they're both the first and third letters, so that works. And then RI and NG, those work. Those are the second two letters. This was C, this is D, E, F, G. D is claiming that TI is the same as NA. That's not right. TI is the first and third, NA is the first and second. So this one doesn't work, it's not true. All right, let's go to E. E says angle T is congruent to angle A. That's true. Angle R is congruent to angle N. That's true. Angle I is congruent to angle G. That's true. Angle A is congruent to angle N. That's not true. A and N could be congruent if it was an isosceles triangle or if it was an equilateral triangle, but we're not given that information, so we can't be sure. Okay, so that's it for that one, and that's the end of part 4.